Hey everybody, today we're going to be working on a fun little project in which we'll showcase the streaming of IoT telemetry events in real time using .NET Core. More specifically, we're going to be focusing on SignalR and Blazor, which happen to be the components of .NET Core. Moving on, here is our project overview. As you can see, it's a very simplified use case in which you have an IoT device generating telemetries which are sent to the web server for them to eventually be consumed inside a web page. And inside that web page, we'll be displaying those telemetry values in a real-time chart. This is actually a watered-down version of a use case that I got to work on in one of the industrial IoT projects that I had the opportunity of working on in the recent past. Quite honestly, that use case was way more complex than this one because we were using the telemetries to drive the automation of certain manufacturing processes. But before we get into the .NET stuff, the question arises as to how to enable the web clients to post the data off to a web server. So one of the more popular options available is by way of exposing a RESTful endpoint on the web server that acts as the listening post for the data coming in. So imagine if your device is generating data at the sampling rate of 1 second, that actually means that at the turn of every second, a call is being made to the REST endpoint, and when the call is being made, a new TCP connection gets created, the request is serviced, the response is sent back out, and the connection is closed. And that happens after every second or so. In reality, the IoT devices could send the data at a much higher frequency, maybe let's say 10, 20 milliseconds or so. So because of those considerations, going the RESTful endpoint way is not suitable for this project. And our use case actually is more real-time in nature. So I'll give you a couple more examples of real-time apps. So imagine if you're developing a dashboard to showcase the performance of stocks, those values get updated in real time. Or if you're developing social media apps or chatting applications or video games for that matter, in which the requirement is to stream the data off to the server, and that data could actually be related to the scores or the state of the players within different levels inside the game. Okay, coming back to our use case. So we are going to be focusing on a mechanism, a real-time transport mechanism, which is different from exposing the endpoint. And an example of that could be WebSockets. So instead of creating a connection every time there is data that comes in to the server on the endpoint, we just create the connection only once and we keep it persistent, which means, or rather it's akin to laying down the pipework. So the moment you have the pipework laid down, you stream the data from the client to the server through that pipework. And WebSockets are bi-directional also, and hence they are known as full duplex, which means that you can send the data from the client to the server and from the server back to the client on the same TCP connection. Okay, so let's discuss this messaging architecture a little further here in this slide. So we have an IoT device. By the way, during the course of this implementation, we are going to be simulating the IoT device using a node.js client. Anyhow, so the IoT device is connected up to a SignalR hub. Wait, SignalR? I've been talking about WebSockets this whole time, but where did this SignalR thing come from out of the blue? Don't be concerned. It's a developer-friendly abstraction that is built on top of real-time transport mechanisms such as WebSockets, long polling, and server-side events. It comes with .NET Core, and during the course of this implementation, we're going to be using SignalR. Anyhow, so we have, coming back to the use case, so we have an IoT device that streams the telemetries off to the SignalR hub, and on the other side of the equation, we have the web UI that is also connected to the same SignalR hub, which happens to be the consumer of that data. So the IoT device is the emitter of data, and the web UI happens to be the consumer of data, and SignalR is helping facilitate that transmission from one end to the other. Okay, show me the code. That's when we start talking about the fun stuff, and I move away from this PowerPoint presentation and move into the terminal and Visual Studio Code. All right, I'm on my Mac and I've opened up the terminal. First off, let's verify if I have .NET installed on the system. So I'm going to say .NET version. All right, confirmed. I have .NET 6 installed on the system. Okay, let's go ahead and create a scaffold app. And to do that, let me find out what templates are available in the system. Okay, so for this project, we're going to be creating a Blazor server application. You must be thinking, what is Blazor? So Blazor happens to be the latest and greatest web framework that Microsoft has ever released. As per them, that happens to be the fastest web technology that they've ever come up with. All right, so with that out of the way, let's go back to the terminal and create a scaffold application. Here I'm going to have to run this command, .NET new Blazor server, this guy. Okay, I'm going to say -o, and here I'm going to have to give the name of the project. Okay, that is sample one. Okay, seems like this project is, the scaffold of this project is created. Let's open this one up inside Visual Studio Code. Insiders. All right, seems like everything has just been created by the .NET new command. Anyhow, okay, go to the debug option here. We need to create a launch.json file. Here you have to select a .NET 5 Plus and .NET Core while choosing the environment. Okay, we do that. Now we have the launch.json file created automatically. We have to now run this application. It's gonna take a moment. All right, there we have it. Seems like the .NET, rather the Blazor server application or the template application has been created successfully and is now up and running. Okay, with that out of the way, we need to now sort out some dependencies. All right, so where is my terminal? I go online. First off, I need to install or add this package, ASP, oh sorry, Microsoft.ASP.NET Core.SignalR.client. It's a SignalR client here. All right, so let's go back to the terminal. Okay, and paste this in. Okay, so now we have a SignalR client installed as well. Okay, we also need to pull Plotly in. Okay, so for the development of the real-time chart, we are going to be using a very popular library, which is known as Plotly. And this is how you pull this library into your project. So go to the library's website, which is plotly.com. Copy the CDN link. Go back to your Blazor project. Open up the layout page. Go all the way down. Just underneath this specific line. Okay, paste the CDN link. Okay, voila, we have it pulled in. So those two dependencies are now sorted. Okay, now under root folder, I'm going to create a folder called JavaScript. And inside this folder, I'm going to create a file called script.js. This file will house all the JavaScript related code that will come in handy in a moment or so, because that is where I'll write all the necessary code for the creation of the plot and its dynamic rendering as and when we start getting the telemetry information from the soft device. Okay, but for me to be really sure of whether I'm able to call it from a Blazor component, I'm just going to create a test method. I'm going to call it show alert. It's a very simple method. say message. Okay. And here I'll just do alert message. All right. All this function does is it just gets a message and shows that in an alert window. All right. So now we need to make sure that we are able to call that through a Blazor component. But before we could do that, go back to the layouts file. And here we'll have to add another script tag, script, okay, src, okay, this, and I'm gonna say Java script slash script dot js. All right. I think we're done with the configuration. Let's go to the Blazor component. I'm gonna reuse this index.razor file. And first off, let me open up the code block. Okay, I think that's how you do it. Okay, so in this code block, I'm going to write a button handler, private async task, call it button get. Oh, but before I could do that, let me inject IJS runtime. Okay. Inject IJ run. Right. I'm gonna call it JS runtime. That's done, and I'm gonna be making a call, or rather, I'm going to be invoking that JavaScript function that test JavaScript function that I just wrote a moment or so back. Invoke. This is JS runtime. JS runtime dot invoke void async. First parameter is the name of the JavaScript function. Go back in here. I named that as show alert. Okay, go back to the Blazor page. The second parameter is the actual parameter that gets applied to this function. I'm going to call it hello world. And now that we have the handler ready, let's create a button. Okay, call it button on click. Go to button click. All right. Okay, test. Okay. Let's see if you're able to invoke that JavaScript function from the Blazor component. All right. Let's run the app one more time. Okay. Voila. All right. So we are able to successfully call the JavaScript function. Awesome. Okay, it's time for us to create two helper functions inside the script.js file. Okay, I'm gonna close this page. Okay, go back to script.js. All right, here we are. I'm gonna start off by creating a function called create plot. Okay, it takes in chart ID as the parameter. Okay, this is the ID of the div that we'll be creating on the Blazor component, basically the HTML part, which is going to be the holding area where the plot will be created as and when the Blazor component loads up. Okay, with default values, that is. So we need to create the plot with default values in this function. So okay, I'm going to start with creating a variable called time, okay, date. All right, then an object called data. Basically, it's an array of objects. I mean, this is all plotly. This is how the library is expecting us to furnish the parameters. Okay, so on the x-axis, we need to plot the time. Okay, on the y-axis, a default value of let's say 0. Then mode is lines, which means it's going to be a line chart. And last, we need to specify the color of the line. Okay, so I like dark red color. I think the color code is um, it's 8B00000. Okay. Okay, this is the data object that is now created with default values. Plotly dot new plot. Okay, chart ID and data. All set. Okay, so now I'm going to create another helper method. I'm going to call it extend plot. Okay, so what happens when we start getting all the telemetries in? Okay, that's when we'll call this function. Okay, and this function will help plot those telemetries on the line chart, and also that line chart will be moving along the x-axis. We call it the extension of the plot. Okay, I'm going to say chart ID is the input parameter and also the telemetry value. Okay, that's how it's going to look like. Okay, we'll start with creating a variable called time, new date. Okay, then update. This is the updated data point information that goes into the plot. On the x-axis, we have, I know it looks funny because it's an array of arrays, but you can't help it because this is how Plotly is designed. Okay, on y-axis, we need to plot the temperature value. Cool. And that's it. Now I'm going to create a date range between, or the time range rather, between which this telemetry will be plotted. I'm going to say, and I'm going to create a minute view. So for me to create a minute wide range, this is what I'm going to have to do. So old time is equal to time dot set minutes. Okay, time dot get minutes. It's one. Future time. Minutes. Time. Minutes. Okay. So from now this is like date, the current time -1, and the current time +1. This becomes our time window between which our data point is going to get plotted. Okay, and this is, I mean, you'll see that in a moment's time because let's create the minute view. Okay, so in here, let's create a variable name is x-axis. There we go, type. And the range on the x-axis is going to be not this range, smaller. Okay, older, old time, and future time. All right, I think we are all set here. Okay, now we are going to create two very important functions. Okay, relay out, ID and minute. Okay, this function helps in updating the layout object of an existing plot. So how do we know we are updating the layout of an existing plot is by way of passing in this chart ID. So we use this chart ID to create the plot in the first place. Now that we have the plot created, we are going to be using the same value or the same div ID to update the existing plot. This is by the way the name of the plot here. Okay, plotly dot extend says, I'm gonna say chart ID update object this value here. Okay, this method. Okay, so what as I mentioned earlier, so as and when we start getting the telemetry values into the plot will start moving along the x-axis. It will start, I mean, getting extended on the x-axis. This is the function that enables the plot to perform that function. Okay, I think we're all set here. Let's go back to our Blazor component to wire the UI up. Okay, so there we go. We open up our index.razor page. Okay, I don't think we need all that stuff in here anymore. Okay, let me do some cleanup. Say, I'm gonna call it the temperature. Let's telemetries plot. Okay, and the core block here, I'm gonna have to override an event handler. I'm gonna say protected override is async task on async. Okay, it takes in a boolean first. Okay, if first render, then call JavaScript await JS runtime. This guy, name of the function, and input parameter to that function. So the name of the function here that we're going to be calling, let's go back to our JavaScript file. This is the one. So we need to create the plot. Okay. And the parameter, oh yeah, so we need to also create the div. Div ID, I'm gonna call it temp chart. There we go. So this is where the plot is going to be created on the UI. And this is the ID of the div that we need to pass in as a parameter to that function. This, okay. So let's see how things look like after all those changes that we have made. Go here. Awesome. See, now we have the plot created with the default values. All right, awesome. Okay. Let's go back to our project. And you must be thinking about this function now. Okay, this will come in handy after we are done setting up the messaging layer through SignalR. And we'll start doing that now by creating the SignalR hub. Okay. Here I'm going to create a folder. I'm going to name it hubs. Okay. Then I need to create a file inside that. I'm going to call it hub.cs. Let's write some C# code using system.threading tasks. Now I'm going to have to bring in the SignalR namespace. Okay, this is VNet Core SignalR. There we have it. Okay, and I'm going to give it a namespace of its own. Okay, namespace sample1 dot hubs. Okay. So let's create a class called public task. No, oh no. I need to create the class first. So public hub. It extends from the hub class. Okay, inside that class, I'm going to write this method. Public async time today. Okay, task message string machine. Okay, string telemetry. Okay, and then I'm going to say await clients dot all dot send async receive message event. Search. Let's say machine telemetry. This is okay. So this line number 12 signifies that as and when the telemetries are received by the hub, those telemetries get broadcasted off to all the connected clients, and that is something we'll be discussing in further detail after I am done showcasing the soft Node.js device. Okay, now that we have the hub created, it's time to configure that hub in this project. Okay, let's go to program.cs file here. Let me open a couple namespaces of Microsoft. Code response compression. Okay. So hubs using sample one dot hubs. Okay. First off, we need to add the response compression middleware to the services. Builder.services.add a response compression. Okay. Options, line types, response compression. I think this is the one defaults. Line types dot cat. Inside this guy, we have to specify a new cat slash object. Okay, so this is, and then we need to also in here, just above this guy, and say dot response compression. Okay, we are telling our project to use the response compression middleware. Okay, so this response compression middleware comes in real handy because it reduces uh, the bandwidth utilization. Okay, that said, let's go and create the endpoint for SignalR. Okay, I'm going to say dot. Okay, map hub. Do we have a? Okay, I'm going to say temp hub is my hub, and the name of the endpoint is going to be okay /temp hub. Awesome. So we are all set with the configuration of our SignalR hub. Okay, the connection hub. Awesome. Now we need to use that inside our Blazor component. Okay, to enable our component to process the incoming telemetries and then hand off those telemetries to our plotly helper function so that they get plotted on the real-time chart dynamically. Okay. Let's do that now. Okay, let's go to our Blazor component, the index.razor page. We need to add more functionality to that. Let me pull in the SignalR client, Microsoft.ASP.co.signalr.client. Okay, I'm also going to inject navigation manager. Navigation manager. I'm gonna call it navigation manager also. Okay. Right. Here I need to create the hub connection. Connection. Cool. So this is created. Now we need to use this object to build the connection to the hub. So I'm going to say hub connection is equal to new hub connection builder. Say with URL. Here I need to use a navigation manager. Navigation manager. This guy to absolute URI. Okay. Say do a build here also. Okay. Coming back in here. Okay. Here I'm gonna specify the name of our endpoint. This is the name of our endpoint, SignalR endpoint, that is. Yeah. Here. Now here I'm going to paste a few lines of code, and I'm going to explain as to why I did what I just did in a moment. Okay, so this is a hack. Don't do that in production because here I'm bypassing SSL/TLS exceptions. Okay, but since it's a test project, so it works kind of. But if we don't put those lines of code in there, then our project is going to run into SSL validation errors. Okay, now that we have built the connection here, okay, I'm gonna then do this hub connection dot listen in for the incoming telemetries. All right, this is what I'm doing here. String. Okay. Okay, in here, I'm going to say on receive message event. This IntelliSense is killing me. Machine. And then telemetry. Okay. In here, as and when we receive the telemetry, so make sure that I'm printing the telemetry value on the console. Okay, this guy, let's see. Okay. Awesome. Console dot write line message. Okay, and the last step is to call the JavaScript function, but this time around, this function instead. Okay, let's invoke it. Wait. JS runtime dot invoke void async. Name of the method, chart ID. Okay. Chart ID was then chart. What's the name of the method? Go back to scripts file, the script.js file. Okay, this is the name of the method. Copy this off. Awesome. I think we're done with setting up our UI, the Blazor component that is. And now the last piece remains, which is the node.js based soft IoT device. Okay. And I'm going to be showcasing that in a second. All right, so last step of the project, or last piece in the puzzle, if you will, is our Node.js based soft device that I've already developed, but I intend to give you guys a quick walkthrough of the code here nonetheless. Okay, I'll start with package.json files. As you can see, I'm using only one package here that happens to be Microsoft's official SignalR Hub client. Here in the client.js file, the first line of code, don't do that in production because then I'm completely bypassing the SSL/TLS validation. But since it's a test project, so it kind of works. Here we are pulling in the client. Here we're making a connection to the hub, pretty standard stuff. Here, this is a very interesting piece of code, but I'll come to that in a second. But if you were to pay close attention to line number 18, here we are determining if you were able to make a successful connection to the hub or not. But once determined, here we are sending a random telemetry value out to the hub at the turn of every second or so. So here at line number 22, we are sending the message out. Here I'm just like, giving a fancy machine name here, like temperature probe 1, and the last parameter is the randomized string. Coming back to this piece of code as to why I termed that as an interesting piece of code is because one half of this client is responsible for sending the data off to the hub, and this half of the same client is responsible for receiving the message, the same messages from the hub itself. So we are just like looping back the transmission back into the client. I just did that to ensure that my connection to the hub was established successfully. But if you were to take a closer look at the hub that we developed a while back, there we have it. And I mentioned that earlier also that this line of code enables the received telemetries to be broadcasted off to all the connected clients. Now, one of them clients is our soft device here. Okay, so it's listening on the receive message event. And the other connected client happens to be our Blazor component. Okay, here. Okay, it's also listening for the same event. So every time an event is fired from one end and it gets received by the hub, a copy of that is received to all the connected clients. And in this case, as and when we receive the data packets, we are just sending off the telemetries to our plotly helper function here so that we could plot that as a data point on the real-time chart. Okay. With that said, let's test everything out and see if things work according to the plan. So I'm going to start off by launching the .NET side of the project first. Okay, let's load it up on my other monitor. Let me pull this one in. Okay, there we have it. And let's go to our Node.js client. Say node space client.js. Okay, as you can see, we are receiving the messages from the hub directly as well. Okay, let's go and take a look at the Blazor page. Oh, nothing is getting plotted here, so I may have missed something. So let me go back and take a quick look. Okay. There is a Blazor component. I think I found it. Sorry about that. It's the hub connection dot start basic. That should settle it. Okay. Trying one more time, and I'm pretty confident this is going to work this time around. All right. Okay. Let's go and start our soft device. Okay. Voila. Okay, so this is working. So our whole solution is now working end to end. Let's go back to the slide deck. I think there we go. Okay. And this slide in particular, see, our soft device is sending the data stream off to the hub, and on the other side of the equation, we have the web UI that is consuming all that data and is plotting those data points on the real-time chart. Okay, and this is how it looks like in the technical world. This is our soft device. This part data gets sent off to the hub. Okay, and on the web UI, it's getting plotted as well. Awesome. All right. So thank you so much, guys, for staying with me till the completion of this project. And if you have any questions and if you're interested in seeking some expert opinion on some of the IoT initiatives here that you're thinking about embarking on, then please feel free to reach out to us, and our contact details are going to be made available to you at the end of this session. Okay. With that said, until the next time, take care. Thank you.